Section 8.1 is adding and subtracting polynomials. I can classify, add, and subtract polynomials. Big ideas. Monomials can be used to form larger expressions called polynomials, and polynomials can be added and subtracted. A monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So it could be like a 5. It could be like a y. It could be like a negative 2x squared y to the third power. Okay, the big idea here is that we don't have negative exponents, we don't have fraction exponents, and we don't have anything added or subtracted. There's only one term. Keep in mind, terms are things that we add together. Factors are things we multiply together. So only one thing here. It can be multiplied together with factors, but no other terms being added together. The degree of a monomial is the sum of the exponents of its variables. In example 1, we're going to find the degree of a monomial. We want to know what is the degree of each monomial. So here, my exponent is a 1 if it's not listed. And since I only have the one variable, my degree here is 1. In B, I have 3 x's and 2 y's, which gives me a total of 5 variables. It's like if I listed them all out and counted up how many variables total I have. Here, 5. In C, I have 0 variables, so my exponent would have been a 0. It's like if I'd have taken it times x to the 0 power. And we know that anything to the 0 power is just 1, and 4 times 1 is itself. So we have no variables. 0 is our degree. You can think about it like that 0 exponent, which just gives us 1. Now, feel free to pause here and give this a try if you'd like. What is the degree of each monomial? Well, if we look here, our exponent on our x is a 1, and our exponent on our y is a 1. So if we add those up, we get 2. Here I have degree 2. I have 1x and 1y, 2 variable factors. In B, same idea. Don't forget that our exponent on the z is a 1. So 4 plus 1 gives me 5, and that's my degree. We add up our exponents on our variable terms. It's like, again, if we'd have listed these out and counted up how many variables. 1, 2, 3, 4, 5. But rather than writing them out and counting them that way, we can just add our exponents and it works the same way. And with the 11 here, we have no exponents, so our degree is 0. In example 2, we're going to be adding and subtracting monomials. So here we're going to find the sum or difference. The big idea here is that we're going to be combining our like terms. And just like we've done before, when we combine them, they have to have the exact same variable part. So here, it's not just because it's an x, it's because it's an x squared and an x squared that we can combine them. Okay, same base here, both x's, and same exponent here, both 2's. So because they're the exact same variable part, I keep that variable part, and then I perform the operation on my coefficients, or the numbers in front of my variable. 3 plus 5 is 8. So here I have 8x squared. In B, same idea. I have x cubed and y. So I have the exact same variable parts. Since those variable parts are exactly the same, I keep them, x cubed and a y. And from there, I can perform the operations on my coefficients. Remember, if there's not a number in front, it's a 1. So 4 minus 1 gives me 3. 3x cubed y. And again, we keep that variable part exactly the same, and it matches what it was in our original expressions. And we can only combine them if they have the exact same base and the exact same exponent. Now, feel free to pause here and give this a try. When we're looking to find the sum here, they have to have the exact same variable. So x to the 4th power, x to the 4th power. Same base, same exponent. And because they're the exact same, I can keep that variable part and perform the operations on my coefficients. Negative 6 plus 11 gives me 5. So I have 5 times x to the 4th power. In the second one here, same idea. I have x squared y to the 4th. And because that's exactly the same in both of my factors, I can combine them. I keep my bases the same and my exponents the same. So since it's x squared, I keep it x squared, and since it's y to the 4th, I keep it y to the 4th. And from there, I perform my operations on my coefficients. 2 minus 7 is -5. So I have -5 times x squared y to the 4th. Again, keep in mind they have to be exactly the same. If we would have had 2x squared y to the 4th minus 7x 4th y squared, we couldn't have combined them, because even though we have the same bases and the same exponents, they're not the same exponents with the base. So we need x squared x to the 4th. Since those aren't the same, we can't do it. Y to the 4th y squared. Since those are not exactly the same, we can't do it. So it's not just all the pieces, it has to be the exact same thing. Like if we listed them all out, x squared y to the 4th is not the same as x to the 4th y squared. So since those aren't the same, we can't add those up, and this would be as simple as we'd get. A polynomial is a monomial or a sum of monomials. Poly means many, mono means one. So it can be just one thing or a sum of monomials, which means a sum of different terms, different things added together. Standard form of a polynomial means that the degree of the polynomial decreases from left to right. So it would be like x to the 5th, and then x to the 4th, and then x cubed, and each time our exponent gets smaller. Okay, we don't have to have every one. We could just have x to the 6th plus x squared plus 1 if we wanted. We don't have to have every degree, but they do have to go from biggest to smallest. And when we're talking degrees, remember we're talking about our exponents, our combined exponents. The degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. So here, in the first one I wrote, my degree would be 5. In my second, 6. So we just look at that leading term, okay, once it's in standard form, the front one has the highest degree, and so we look at that one to figure out what is the degree of our polynomial, because they're going to match. We can name polynomials as shown in the box on page 487. So here we're going to name polynomials by degree and by number of terms. So degree for a constant is 0. Those are things like 5. I think the book has 6. Okay? If we had 5x minus 2, for example, our degree is 1, and we call that linear. If we had 3x squared minus 2x plus 6, our degree here is 2. We call that quadratic. And again, these are in a chart on page 487. And if we had 3x cubed minus 2x, our degree here is 3. And we call that cubic. And that's probably the easiest to remember, x cubed cubic. Here is linear, like when we made a line graph, if that was equal to y, it'd be like slope-intercept form. And quadratic is something squared. A square is a quadrilateral. And that's kind of how those go. Number of terms, here we have one term. We call that a monomial. 2 terms, 2 different things added together. We call that a binomial, like 2 wheels on a bicycle. Here we have 3 terms. We call that a trinomial, like 3 wheels on a tricycle. Mono means 1, bi, 2, tri, 3. If we have anything more, so 4 plus, we would just say 4th degree, 5th degree, 7th degree. And if we have any more than 4 terms, we just say polynomial of 4 terms, polynomial of 8 terms, things like that. So again, make sure they're in standard form. and then go from here. These 7 words you will be responsible for knowing. They're going to be very common. We're going to use them now to start describing our expressions. So constant is degree 0, no variables. Linear, 1. Quadratic, 2. Cubic, 3. Monomial, 1 term. Binomial, 2 terms. Trinomial, 3 terms. And from there we would just either say 4th degree, 6th degree, or polynomial with 8 terms. Okay, they don't have special names after that we're going to use. In example 3, we're going to classify polynomials. We're going to write each polynomial in standard form. So for it to be in standard form, we need to go from biggest exponent to smallest exponent, and we need to make sure that all of our like terms are combined. So if I look at A, I have an x squared, degree 2, and an x to the first power, degree 1. We put our biggest degree first, so our highest degree, and then because 3 is positive, we go plus 3x. Now it's in standard form. From there, we're going to name it based off its degree. Here, our degree of our first term, we said, was 2. Second degree, we call quadratic. In our number of terms, I have 1, 2, or 1, 2. Binomial. So it's a quadratic binomial. We usually do degree first and then number of terms because these are like quadratic, cubic, things like that they use to describe the next word. If you do it in the opposite order, not the end of the world, as long as you're aware of which parts work for which things. So as long as you know which labels for degree and which labels for number of terms. Here, if I compare, I have a degree 1, 0, 3, and 1. My 1s I can put together. So since I have the exact same variable, I keep that and add my numbers. 7 plus 4 is 11x. Okay, but my degree 3 has to go first. So 5x cubed, then my 11x, and last minus 1. Again, biggest degree on down. So I have third degree cubic, I have no quadratic term, I have a linear term and a constant term. Standard form. Now, because my degree is 3, this is cubic, and because I have 3 terms when it's in standard form, it's a trinomial. Cubic trinomial. Now, feel free to pause here and give this a try if you'd like. We're going to write 2x minus 3 plus 8x squared in standard form, and then we're going to name it based off its degree and number of term. So standard form means we're going to put it in order from biggest degree to smallest. So here my degree is 2, here my degree is 0, here my degree is 1. So since 2 is biggest, we put that term together. And since none of them are the same degree, we can't combine them. We don't have the exact same variables. So 8x squared plus 2x minus 3. And this is standard form, biggest degree to smallest. Now to label it based off its degree, we look at just our leading term here. Our degree is 2 there. And degree 2 means quadratic. Our number of terms is 3. There's 3 different things added together. And 3 terms means it's going to be a trinomial. So 8x squared plus 2x minus 3 is a quadratic trinomial. And that's all I have here for the first half. We'll continue in another video.